So here I've intersected and trimmed all the surfaces to create the main spoke shape, and I've also applied a fillet to the edges using the round tool. Now the round tool is limited to G1 tangent continuity, which means that if I toggle off the model, you can see that the highlight is quite distinct when it goes from the circular round onto the flat edge. So it's smooth to the touch, but visually it's a bit crude. We've also got a few typical problems here. So up at the top, the original intersection hasn't been covered up by the round. So you'd need to do some untrimming, deleting old curves on surface and retrimming. But also this corner here hasn't worked because it runs across the edge of this surface. So the advantage of the round tool is it'll create the corners for you when you have 3 or more edges coming into a single point. But it's mostly used on small detail fillets and not as part of the main design like we've got here. So my alternative is to use the surface fillet tool, because this has G1 tangency, but it also goes up to G2 curvature or even G3 curvature. But the surface fillet isn't able to build these corners. So we have to think carefully about which order we build the fillets in. So if I take a look at the top here, I know I'm going to want a small fillet running around that edge. But it won't go across this sharp edge because of the tangent break. So I'll need to put the fillet onto that edge first. So I'll fillet those 3 against those 3 surfaces, and I'll just check that my arrows are in the right direction, and normally they are by default. And I'll just increase the size of the fillet up to 5. And I've got it building to G2 curvature here. So that's created. So I'll just go and check the end conditions, and default on the center line should be fine. But up here it's set to extend, which is probably what I want, because default wouldn't trim this front surface. And although edge align achieves the trimming, it gives me these distorted CVs. So I choose to stick with extend, because I'm going to trim this later anyway with another fillet. And if I shade that up and toggle the model off, then you can see I get a much more subtle transition into the fillet with G2 curvature. So I'll continue and fillet the sides to the rear, and I'll just check the directions, and I'll make this one a bit smaller, so I'll try 3. And the default and the extend at the top are working okay. So now, around the spoke, I've got a ribbon of tangent continuous surfaces, which means I can now fillet all of those surfaces against all of the rim surfaces. And I'll just check the arrows, and that's the right direction, and build the fillet. And it's done a good job. And it's even gone round that tricky corner at the back that crosses these 2 surfaces. And that's because the surface fillet isn't concerned with edges, it works from the body of the surfaces that it's blending between. Now, because of the different angles between the different sides of the spoke, we've got quite a variation in the width of our fillet. And I'm just going to increase that size to show you how the fillet can fail. And it's gone dotted, which shows that it can't build. And if I just knock that back to 6, you'll see why it's failed. Because over here in the corner, that edge down at the bottom is getting smaller and smaller, and eventually it'll crash into itself, which is why the surface fillet will fail at the larger value. And another reason to show you this large value is that it exaggerates the difference in width that a fixed radius fillet creates here. So this is where I might try the chord calculation. And this works on a fixed width rather than a fixed radius. And in this situation, it should give us a much more consistent looking blend. And I can make that a bit larger. Now, when you use a chord fillet, you've got 2 choices for specifying the size: chordal length or tangent length. And I normally just experiment between the 2 to see which gives me the best result. But they're also explained in more detail in the first continuity theory builder. So chordal gives me the best result in this case. So I'll just check the end conditions, and I don't want to extend, default should be more accurate on the center line. So if I take a look at that, then I get a more sophisticated result than I had with the round tool. And then to finish off, I've got some curves to put a hole detail into the spoke. And one of the really nice things about Surface Fillet is that we don't need to intersect and trim first. So I can just project the curves onto the front surface and then build the draft surface directly from them. I don't need to trim the front surface first, because the fillet will do that later. So if I now fillet these three surfaces against that front surface, and I'll just do a normal radius fillet and a fairly small one for now. And I can build that, and it does the trimming and creating the fillet surfaces at the same time. Now, I didn't realise my fillet was going to go across onto that lower surface. So I'll just do it again, and this time choose both those front surfaces and fillet against these three. And I can make that a bit bigger. And the other nice thing about recent developments in Surface Fillet is that I can also choose to have that as a chamfer instead of a blend. So if I go back to the control window and choose chamfer, then I get a nice sharp-edged detail. So finally, I could do another fillet at the back, but I'm just going to intersect and trim to tidy up the spoke design, ready for stitching for export in the next tutorial.